Okay, folks. Today we're going to be doing section 3.6, which, as I intimated last time, is all about trigonometric derivatives. So the meat of it is just what are the derivatives of the trig functions, right? So the section itself goes into more detail. It actually shows sine using the limit definition of the derivative and a bunch of trig identities. And it turns out that that just gives us cosine. It uses, does it? I don't think it actually works out how to get the derivative of cosine, but it's very similar to how to get the derivative of sine. And it turns out that it gives a very similar answer. It gives negative the coversion, right? So sine gives you cosine, cosine gets you negative sine, right? And all of the trig derivatives actually work in a matching pair like that, right? So the derivative of tangent of x gives us secant squared x, and its matching pair is cotangent, right? So two co-functions, same as our first pair, and it's, again, similar to our first pair, gives us a very similar result. It's, instead of secant squared, it's cosecant squared, and instead of positive, it's negative, right? So it matches up in the same sort of way. And the last pair is that the derivative of secant x is secant x tangent x, and the derivative of cosecant x, you can hopefully guess, is going to be negative because the other one was positive. Instead of secant, it's going to be cosecant, and instead of tangent, it's going to be cotangent. So, now that we have these 6 derivatives, we can figure out a whole bunch more fun examples. So let's have a problem where we find the second derivative of for the function secant x. Right? So, like when we introduced higher derivatives last time, we've got to get all of them up in order. So if we want to find the second derivative, first we have to find the first derivative. And thankfully the first derivative we already have, right? That one was nice and simple. We just read it from the list. We get secant tangent x. But now comes the tricky part, because to get the second derivative, now we have a product of trig functions. So we need to use the product rule. So we're going to have the derivative of secant times tangent plus secant times the derivative of tangent. All right. So the derivative of secant, we can look at our list and see that that's secant x tangent x, right, times tangent x. The derivative of tangent x, we look up here at our list, and we see that that's secant squared x. So we can simplify this to secant x tan squared x plus secant cubed x. All right. So mostly all these problems are going to be practice for all the stuff we've talked about before. It's just occasionally we're going to get down to a step where we answer it by pulling from that list. Right, so let's say we want to Find the derivative of for f of x equal to e to the negative x cosine x. Right, so here we even have to be a little bit clever before we get started, because when we look at it, this looks like a product, right? We're multiplying e to the negative x times cosine x, right? And eventually we'll be able to do that one as a product, and it probably will honestly be the best path to do it as a product. But as it stands now, we can't do it as a product because that would mean that f prime of x is equal to the derivative of e to the negative x times cosine x plus e to the negative x times the derivative of cosine x, and I don't know what this is yet. Or rather, we should say, in this class, we don't have tools to figure out what that is yet, right? That's not the same thing as e to the x. It's a different function, so we don't know how to deal with it yet. But, so we have to be clever and realize that another way to write f of x is cosine x divided by e to the x, right? You can always change where something is on a fraction by changing its power from positive to negative. And in this case, because we don't have certain tools yet, and for anybody coming back here to study, the tool that we need is the chain rule. So if you already have the chain rule, then you can probably figure out how to do this one, the derivative of e to the negative x. But without the chain rule, we have to use the quotient function, or the quotient rule, right? So later on, we'll have our choice between the chain rule and the quotient rule, but for now, we're going to do it by the quotient rule, right? So what that means is we need to figure out what low is, and that's e to the x. D low is just e to the x again. High is cosine x. D high is negative sine x. Right, so now we can plug into our formula, and we know it's low d high minus high d low over the square of low we go. And now if I want to simplify that, we get negative e to the x sine x. Because remember, this is being multiplied, it's not being subtracted. Got to be careful with your parentheses for things like that. E to the x cosine x, and all over e to the 2x. Right? You don't necessarily have to change this order to simplify it. I just like to have nothing coming after cosine if I can help it. But it is good to bring that out front just so that it doesn't look like there's subtraction there. And then to simplify raising a power to a power by multiplying those powers together. Right, so this is our derivative. Right. Let's see. Let's find the tangent line to the graph sine y equals sine squared x at x equals pi over 4. Right? So, if we recall, tangent line to a graph is going to be y minus f of a equals f prime of a times x minus a. So we're going to need to figure out what the derivative is with a plugged in. We're going to need to figure out what a is, sort of a priori to that. And we're going to need to figure out what the function itself is with a plugged in. Now, whenever you see this at for these types of problems, this is telling you what a is, right? So a equals pi over 4 for our purposes, right? So f of a equals f of pi over 4, right? And remember, secretly in this notation, whenever you have y equals something, that's f of x equals that something. So this is sine squared of pi over 4. Right, now pi over 4, when we plug it into sine, this is one of those things that you either need to remember, or if you can't remember, because, hell, I didn't remember until I taught this class a million billion times. But sine of pi over 4 is root 2 over 2. Right, that's one of the things you should be able to remember or look up. So this is 2/4, 1/2. Okay, so we've got two of the pieces we need. We've got that. We've got that. Now we just need to find the derivative. So first off, we're going to find the derivative as a function. Right, and one of the things that we notice is that we again have to be a little bit clever. I'm leaving us room to be clever, right? Because yet again, we don't have a lovely little thing called a chain rule. And I might be playing it up because next section is the chain rule and I want everybody to get hyped for it. But we don't have the chain rule yet, so we don't know how to deal with sine squared x. But if we remember that sine squared x is really just sine x times sine x, well then now we can use the product rule. Right, so this is an option where later, if we were doing this problem, we could either use the chain rule or use the product rule. But for now, we're going to have to use the product rule. So that says it's going to be the derivative of the first sine times the second sine plus the first sine times the derivative of the second sine. Right, derivative of sine is cosine. In both of those cases, it doesn't matter what order you're multiplying things in, so this is really just 2 cosine x sine x. Right? And now what we really want is f prime of a, so that's going to be f prime of pi over 4. So that's going to be 2 times cosine of pi over 4 times sine of pi over 4. And pi over 4 is a nice one where the answer is actually root 2 over 2 for both cosine and sine. Right? So this is going to be 2 times root 2 squared all over 2 squared. So that's 4 over 4. So that just gets us 1. Right, so now we go back up to here and we plug into our formula. We figured out that f of a was 1/2. We figured out that f prime of a was 1. And a is pi over 4. Right, so we get y minus 1/2 equals x minus pi over 4. And that is the tangent line to the graph at that point. Right? Alrighty. So now hopefully I've gotten us all good and excited for the chain rule because it's definitely the coolest rule of all the derivatives because I say so. But that'll be what we're doing next time, and that will pretty much blow open the door for all the derivatives we'll be doing. I think we're going to have 1 or 2 more sections where we're going to learn some base functions we can add to this. Like we're going to learn how to do logarithms, and we're going to learn how to do inverse trig functions and hyperbolic trig functions. So there's a couple more sections of that. But mostly, once we get the chain rule under our belt, we'll be set into working on applications and problems using the derivative. So I will see y'all for that type stuff next time.